Hi there, my name is Matthew Guzdial, and I'll be presenting this paper on the impact of visualizing design gradients for human designers. My co-authors were Dr. Nathan Sturtevant and Carolyn Young. We're all at the University of Alberta. Nathan and I are at AIIDE, the Alberta Machine Intelligence Institute, where we're both CFAR chairs in AI there. And Nathan is the director of the Moving AI Lab, and I'm the director of the GRIL Lab. So it's a collaboration between the two of us. Now, before I can get into the sort of content of this paper, I'm going to need to introduce the concept of exhaustive procedural content generation, or EPCG. Now, many of you who are familiar with PCG are going to be more familiar with traditional PCG, or specifically traditional search-based PCG, where you're going to define a space of possible content, where every point in this space is a potential piece of content. And then we're going to start from initially random piece of content, and then keep on taking steps to other pieces of content, guided by a heuristic, until we find some final output piece of content, and then we generate it. Sometimes instead we're generating populations of points instead of single points, but this is the basic idea. Now, in comparison, exhaustive PCG, while it is search-based PCG, is not like traditional search-based PCG. We still are going to have a space where every point in that space is still a piece of content. But instead of searching through the space, we're going to generate every single piece of content in that space, every single point of that space. And then we are going to select from this set of content. So it's a slightly different sort of framing here. Now, exhaustive PCG, as defined by Dr. Sturtevant, has two components. The first is a generator, which unsurprisingly is going to generate every single point in the space. And the second part is the evaluator, which is the important job of actually selecting what content are we going to return from this space. So last year, Nathan and I presented the unexpected consequences of incremental design changes at AIIDE, where we introduced this Inhinga environment, which is a clone of this game called Snakebird. In Snakebird, you play a snakebird that has to try to eat fruit and then get out of an exit. And what we did is we used ePCG to produce all single changes to a level, like adding this one spike here, and then we selected the one change that most increased the minimum solution length, that most added extra things you had to do to be able to solve the level, to be able to complete the puzzle. So our theory here was that even with a single change, ePCG, which is particularly good at finding, sort of proving this is the one change, right? People would be able to tell the difference. And so you can see here on the left, we have the actual level, and on the right, we have the change. No difference yet, but here, you have to be really careful about how you fall. And then here as well, a little bit careful about how you fall to ensure that you get to the exit. And that leads to an increase in the minimum solution length. And perceptively, there was a change. Players actually experienced a difference significantly, finding the levels to be more challenging, frustrating, and interesting when they were the sort of one changed ePCG produced levels. Now, there's a small problem with this, which is that this is all automated evaluation. As anybody who knows PCG knows, automated evaluation is really tough. So this top level, okay, that might be interesting. But on this bottom level, we have a very similar situation where you have to be careful about how you fall. And we have this one block, which sort of cuts off your entrance into the portal, the end state a little bit. And this is not as interesting. So what we were thinking about here is, was there a way that we could have humans instead pick between these possible one changes? And so that's what we did. We built a mixed initiative tool, a mixed initiative level design tool for Snakebird, for our Inhinga environment. Let me walk you through it a little bit. So on the right, we have all the different pieces of content that we've implemented in this editor. On the left, we have the actual level. This is an original Snakebird level right here. And you can see there's a visualization on. Now, this visualization, I'm going to blow this up a little bit, is if we make one change. So in this case, if we replace any of these tiles with sky, which is the currently selected thing, what is going to be the change to the minimum solution length? So right here, if we do get rid of this one, the minimum solution length is actually going to increase by 2. This is to say that it's going to take 2 more steps to make it to the solution, because you can't actually go on top of the fruit in this case. But if we delete this fruit over here, then our solution length is actually going to decrease by 11. So it becomes much, much easier. So you can see how with just a single change, you can get big differences, right? And by iteratively making these changes, you can produce all kinds of really interesting levels. There's one more thing I want to bring up. So at the bottom here, we have level is solvable in 30 moves. We have a solver that's constantly running and constantly checking to see, hey, is the level solvable, which is constantly updating here at the bottom. And then there's also a solve button where people can actually press this and then see the Snakebird solve the level if it is currently solvable. So we ran a human subject study where we had designers design with this tool. We had them first go through a quick tutorial, give them some instructions, and play 3 levels to give them some basic concepts about how does Snakebird work. From there, we had them design 2 levels with 2 variations of our editor in a random order. So the first is the one that I've already pitched to you. We had our full solver and visualization on. We think of this as our full evaluator, because the solver, right, is being used to find the minimum solution lengths, and then the visualization is actually visualizing the largest minimum solution lengths, right? And on the right here, though, we have a version of our editor, which you can not quite barely see, where the visualization is turned off. So this visualization isn't on. We only have the solver. It's still telling you, hey, is this solvable? It's still allowing you to click the solve button. But we only think of this as like half of our evaluator. So we refer to the one on the left as full EPCG and the one on the right as half EPCG. So after designing 2 levels with these 2 different editors, we then had designers go through the survey, where we first asked them to rank their experience in terms of the 2 experiences on a number of features. We asked them to then rank the levels they output to get a sense of how do they expect players to react to these levels in terms of these things, particularly. But we especially want to highlight frustrating, challenging, and interesting because we have a pretty good quantitative measure for those from the last study. We also then gave them an option to do some free response comments. There's some here, more in the paper, and then some demographic questions. The results then I'm going to go over in this order. We'll have first the experience rankings, the level rankings, the quantitative results, which come from some objective numbers from some logging, and then the level analysis. Okay, so first let's cover these experience rankings. So we have the full EPCG rankings here. This is the number of times that the full EPCG editor was ranked as more fun, frustrating, easy, or more preferred, and the half EPCG editor's rankings along here. The first thing I want to bring your attention to is that we have 2 significant differences between our 2 editors in terms of these rankings. We have a significant difference in terms of the full EPCG editor being viewed as easier to work with, much easier to work with than the half EPCG generator, and the half EPCG generator overall, though, still being more preferred. So we had a number of comments on this, and one of them was that I found suggestions to be intrusive to my creativity, here talking about the visualizations. So our takeaway here is that some found that the visualizations were a little overwhelming, or that they felt like they were being guided too much. With that being said, some people did say that they found the solve function to be very useful. So we don't take this as a refutation of EPCG generally, just the way we handled the visualizations. One more thing I want to bring to your attention here is the frustrating rankings. So this might seem like it's nearly 50-50, but in actual fact, 30 of our 34, this is after we had to do a downsampling and made sure there was an even number of each condition, 30 of our 34 responses found the second experience to be more frustrating, which we basically found to mean that people found having to design 2 levels in a row a little bit taxing. After that, right, we had people rank the levels, how they thought players would respond to these. So I first want to highlight fun, surprise, and preference. These, again, look like they're half and half, but that's not it. Again, 2/3 ranked the second level as more fun, surprising, and more likely to be preferred. Now, this is interesting because just a second ago, they told us that they found the second design experience where they made this level more frustrating, but they found the output to be more fun, surprising, and more likely to be preferred. Our interpretation of these results is that people were basically learning how to design levels in Snakebird as they went, and so they thought the second one was better regardless of the case. Now, because we've evenly sampled between things, this doesn't impact the results. The last thing I want to point out here is challenge. Now, this is in bold because it is significant, and basically people thought that the half EPCG levels would be significantly more challenging for players than the full EPCG level that they created. Now, this actually goes counter to our expectations in terms of the quantitative results, and I'll get to that in just a second. So the quantitative results look like this. We have time, the amount of time taken, number of actions, number of times used the solver, and the solution length. So people overall took more time with the EPCG editor, that variation, but they did fewer actions and used the solver less frequently. So we're taking this to mean that this is just the time it took to sort of interpret the visualizations, to understand the visualizations. The solution length, though, is really interesting here because the full EPCG level had a longer minimum solution length than the half EPCG level. And we know that this means that it's more likely to have a moderate correlation with player rankings of challenging, frustrating, and interesting. But the designers just told us that they thought the half EPCG level would be more challenging, even though this would suggest the opposite. Okay, there's one last thing that we're looking at here. So this is this new metric that we're proposed in this paper called solution density. We came up with it before the study, but basically it's the maximum number of times a snakebird's head is in the same position during an optimal solution. This is a metric that we thought might relate to challenge or interestingness because you have to sort of move the snakebird around very carefully for more complicated levels. So what we have here is a graph of the snakebird, or a scatter plot rather, of the snakebird primer levels. The x-axis is the level number, so literally the number in the game, level 1, 2, 3, 4, 5, 6, just as they're numbered in the game as you play them. And the solution density is on the y-axis here. And you can see that there's a correlation where the levels that are sort of higher up in the ranking have generally a higher solution density. And in fact, there's a significant correlation here using Spearman's rho with a rho of 0.55. And what we found is that the full EPCG levels, once again, has a solution density significantly higher than the half EPCG levels. So this is two pieces of evidence that the full EPCG levels are more challenging or more interesting than the half EPCG levels. So some takeaways that we took from the study. First, our visualization did appear to frustrate designers. If we ran a pre-study, right, we suspect we could have gotten around this issue because when we were using the editor, we were just used to the visualization, so we could just ignore it unless we wanted it. We didn't do a comparison to a no EPCG baseline, fully turned off, no solver, but we didn't want to overwhelm users with lots of design tasks. Already, right, 2 was a lot. The visualizations, notably, there's quite a bit of evidence that they did help to produce more challenging, interesting levels, which goes counter to designer expectations. This is interesting. We made a tool to help people make levels that were more challenging and interesting. We have some evidence that happened, but that goes against the designer expectations. We think this is a novel sort of effect, and we're calling it deceptive mixed initiative PCG, where a mixed initiative PCG tool allows the designer to make content that goes against their expectations. Okay, and then some broader sort of takeaways here for mixed initiative PCG generally. We recommend more kinds of PCG be looked at in more domains because we just did one new kind of PCG or newish kind of PCG on one new domain. We got really interesting results from that. From this and from some prior work, users do seem to have a really strong preference for mixed initiative level design to have solvers. So highly recommended. And then this deceptive mixed initiative PCG idea, I think it's a really interesting concept, and I think there's a lot more research needed to figure out when it happens, why it happens, and if it's ever ideal that we might actually want this to happen. Okay, that's it. Thanks so much for listening. Contact information's on this slide. Thanks to NSERC and Amy for funding this research. I really look forward to any questions that you have.